Hi, this is Josh Pierce, and I'm here to introduce the proposal presentation for team number 16, which is made up of myself, Robert Gallipo, Holly Haynes, and Chris McIntyre. On slide number 2 here, you'll see our problem definition. Essentially, we've been hired by a band to create 4 new instruments for them that will allow them to play one of their hit songs while also fitting within some very strict material and size constraints. On slide number 3, you'll see the design requirements for these instruments. It includes all of those specific material and size constraints as well as budget issues that we had to take into account. Final thing we had to make sure to note was that all team members would have access to the necessary tools in order to create the instruments. On the next slide, you'll see the design criteria that my team came up with. You'll see that it includes size, acoustics, cost, creativity, and aesthetics. We assigned a weight to each category, and my team decided that size should be most important, so that's what we're concentrating on. Now onto the proposed designs that we're suggesting. I was tasked with creating 2 string instruments, the first of which is going to be able to play the mid-range notes. That instrument, you'll notice that the bass is made of mostly cheap wooden paneling that is designed so that it can come apart and be put back together so that it fits well within that 2 foot by 2 foot by 2 foot box that we have to create it within. The neck is designed with a hinge in the middle so that it can fold in half and also fit in that box. And then I'm going to use guitar strings of not the lightest gauge so that I can hit those mid-range notes and have it strung from the tip of the guitar down to the bridge that connects to my bass. My next instrument looks very similar to the first. It's a low-range guitar. So what I'm doing for the bass is I'm actually going to be using the 2 by 2 by 2 box that we have to fit all of our instruments in, so that way I don't have to worry about that and that will save on budget. So what I'm designing is a top to go over the bass that's going to have a hole cut in it to allow for my sound to take place. My strings are going to be a heavier gauge, maybe bass guitar gauge, that's able to hit those lower notes. And again, the neck is designed so that it folds in half so that it can all fit compactly within that box.
Hi, my name is Chris McIntyre. I'm a member of Team 16. I was tasked with creating 2 wind instruments for this project. Let's go ahead and take a look at those designs. The first one is a pan flute style. As you can see here, the PVC, this will be made out of PVC tubes cut to length. They'll be stacked side by side. The frequencies are calculated very simply by this formula here. It's the speed of sound over 4 times the length, and get that out of there. What that does is it gives us a frequency range of 858 hertz to 4.2 kilohertz. Let's go ahead and take a look at the second design. Second design is a PVC flute, and it's very similar to a Native American flute. You can see down at the bottom here that there's a little notch out down here where the air will come in through the bottom and excite the air in this tube. Holes will be drilled along the top of the tube to create antinodes, generating all the different frequencies that we'll need. Frequency range of this guy is 317 hertz to 2.14 kilohertz. Thank you.
Hello, my name is Holly Haynes, and I'm a member of Team 16. I was tasked with creating 3 conceptual instruments: 1 wind, 1 string, and 1 percussion instrument. Each one is a high, medium, or low range instrument. The first one is a medium range xylophone. The sound box would be made out of wood with a hollow inside. Each bar would be made out of wood approximately 2 inches wide by 1 inch high at varying lengths connected at the top of the sound box. 1 or 2 mallets would be made out of rubber material. The second instrument is a low-range recorder. The recorder will be made out of a PVC pipe approximately 12 inches long. The top of the recorder will have multiple tone holes where a combination of chords would be played using 3 fingers on both hands. You will blow into one end where the airflow would come out of the pipe at the other end. Various notes are played based on the finger placement. The last instrument is a high-range bass guitar. The guitar would be made out of wood, string, and a few extra pieces that would need to be ordered. The instrument is not exactly a viable option for our team. We would need to build a fretboard, tuning gears, and a fingerboard, and some other parts made for the body that would end up being too expensive and ultimately too time-consuming.
Hello, I'm Rob Gallipo with Team 16. I've been assigned to design 2 percussion instruments. I decided for my designs I'm going to go with the xylophone concept, one constructed out of 1/2 inch copper pipe, the other constructed out of flat bar that is 1/8 by 3/4 inch steel. Both designs are mounted on a wood base and secured with nails and little pieces of rubber. And my goal is to get to achieve the C5 major scale, which means that each piece of pipe or flat bar will have to be cut to desired lengths to reach the proper frequencies as shown right here. And also, part of the tuning is how far in I mount each bar or a piece of steel. The frequencies are found in the equation for percussion instruments as follows: m squared times pi times k times v divided by 8 times L times 2. And each of the variables for the equation are listed here.
As a team, we created 4 different decision matrices to determine which of our designs would be the best solutions moving forward. Based on those matrices, we have determined that we will move forward with designing and building a high mid-range pan flute, a mid-range guitar, a mid-range xylophone, and a low-range recorder. In conclusion, we were tasked with the ability to design 4 instruments for Maroon and Gold 4 to take on their tour. We are confident in the 4 designs that we have developed and are comfortable with the specifications we have laid out moving forward. We believe we have met the requirements thus far and look forward to the development phase in the project. Thank you.